Okay, welcome back. This is lesson 2 on net ionic equation. This is a subject we kind of jumped ahead on in the previous example or the previous lesson. So this should be a pretty short lesson, I'm hoping. So a precipitation reaction is a chemical reaction between ions in solution that result in the formation of a precipitate. The equation of the reaction between aqueous silver nitrate and aqueous sodium chloride is as follows and forms the silver chloride. We may recognize this as a double replacement reaction. All precipitation reactions are double replacement reactions. The equation above is called a precipitation equation or a molecular equation because it shows the ions together as if they form neutral molecules. The molecular equation is not an accurate representation of what is actually going on. It does give us an indication of the contents of each solution, but we know that the ions are not together in the solution. A more accurate representation is the ionic equation, which we practiced in the last lesson. So here is the ionic equation. So we do the dissociation of the silver nitrate into its composite ions, the sodium chloride into its composite ions, and then these two dissociation equations reflect the ions that are present before the two solutions are mixed. Then we take our composite ions, we add them into the equation, and then keep, if we can, find the pairs that make up precipitates and note any pairs that don't and leave them in their ion form. So this is something we didn't do last time. Last time we just were playing around with that, sort of using this as a tool to find our alternate, our double replacement formulas. But now in a true ionic equation, we want to leave the aqueous ions separate from each other. Notice we have not separated the silver chloride because after the reaction is complete, the silver chloride ions are not free to move. They are now held in a solid ionic compound called silver chloride. The ionic equation also includes the spectator ions, whereas the net ionic equation, which we did practice a little bit last lesson, is where we are going to eliminate any of those spectators. So eliminating the nitrate, eliminating the sodium from both sides. The net ionic equation will therefore be just the two ions that are reacting and the solid precipitate. So let's write the complete set of equations for the reaction of lead nitrate. Boy, this feels like deja vu already, but that's because I just finished writing that previous reaction, that previous lesson. Hopefully you aren't binging all of these. And so the lead iodide and the lead nitrate and the potassium iodide are going to switch partners. So we are going to get the lead iodide, and we are going to get the potassium nitrate, and we're going to check for aqueousness. We know that all first column metals are soluble with essentially everything, and nitrates are also very, very soluble. Iodine is usually very soluble, except in the case of mixing with lead. And then we have to do a little bit of balancing. There's a 2 here. I need to slide that over to give myself a little bit more space and put a 2 there as well. Okay, so this is the molecular equation. Now we're going to write the ionic version, where we're going to take any aqueous compound and split it up. So split it up, split it up, split it up. Lead, 2 plus, aqueous. There's 2 of these nitrates, aqueous. Don't forget the ionic charge. There are 2 potassiums, and they're aqueous. There are 2 iodines, and they're aqueous. And there is 1 big old lead iodide, and it's solid. And then there are 2 potassiums, and they're aqueous. And there is 2 nitrates, and they are aqueous. So it is still a balanced reaction. There's no cheating there. You have to balance it. And then we're going to look for any partners that are the same. So here, here, and here, we can take those away and form the net ionic. So only things that are on one side of the equation get carried through. So this one, and this one, and this one. So we got 1 lead, aqueous. We got 2 iodines, aqueous. And those are forming together to make lead iodide solid. There is our 3 equations. Something we've already kind of practiced in the previous lesson. I'm a little bit more formalizing things a little bit, but it is something that we kind of did already just to figure out what kind of chemicals we're forming. And so now we're going to do this in a more formal sense. So I'm going to leave that with you to practice these questions that are written out here. You've got a whole set of them, and that is the end of that lesson. So maybe I will do one example question just to round things out. Yeah, let's try this one. So this is ammonium sulfate, so that makes it NH4SO4. SO4 it has a charge of 2. So we need 2 of those ammoniums, and that's going to be an aqueous compound because with ammonia, ammonium is very soluble. And then rubidium, Rb, carbonate, CO3. Rubidium is a 2+ ion, carbonate's a 2+ ion, but it is apparently, rubidium is a 1+ ion. That's why this works out. It's the only way this would work because carbonates are otherwise insoluble. Isn't this going to have no reaction? I'm giving away the answer, aren't I? 1 second. I'm just going to pull up my... This is why you always should have a periodic table in front of you. Yep. Okay. All right. So when we carry this through, we do a little swap of partners here. Rubidium is going to now be sulfate's partner. And it's also going to be ammonium with the carbonate. And we notice that the chemical reaction is already balanced. I'm going to go back to my rules, but I don't have to because I already know that since sulfate and carbonate have the same rules, they are essentially equally soluble. So both chemicals have been soluble, and so that means that this is actually a no reaction situation. And so we could write it we might as well write out the whole thing. So we will practice our proper writing out of the ionic equation. Oops. I'll write those phases in the full size script with on the line, no subscripts. We're going to follow that IUPAC rule. I'm going to run out of space. No. Okay. 2 minus aqueous. And then I have to get in there and squeeze one more aqueous. And I know it's looking like I'm making a subscript. It's just I'm trying to write it small. Okay. And then of course with the when we look at this from the net ionic equation, we go cross, 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 cross. No, 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 no. All of those are aqueous, so there's no net ionic. Can't have an equation if there's no chemicals. So this means no reaction. There we go. So there's another example or a non-example we can do with a no reaction result. And I will leave you to practice the other ones, and we'll talk to you on the next video.